Imagine for a moment that you could look directly into the future of the universe. Not just a few decades or centuries ahead, but trillions upon trillions of years into the future. What you would see would be something completely unexpected. The answer to when everything we know will cease to exist might be hidden inside you at this very moment. In fact, it's hidden in every atom of your body, in a particle so small and seemingly ordinary that we rarely think about it. Yet it could be the key to understanding the greatest cosmic mystery of all time. That particle is the proton. It sits at the heart of every atom, forms part of every molecule, and literally makes up everything you can touch, see, or feel. But here's what will make you rethink everything. What if this particle, which seems so solid and eternal, actually has an expiration date? What if the proton, one day, simply decided to disappear? The answer to this question wouldn't just change our understanding of physics, it would completely rewrite the fate of the entire universe. To understand how we arrived at this almost impossible-to-believe conclusion, we need to go back to the end of the 19th century, when scientists still believed that atoms were like tiny, indivisible billiard balls. It was an era when physics seemed to be reaching its end, with many scientists believing that all the great discoveries had already been made. What irony, considering we were about to open the biggest Pandora's box in the history of science. The first to shake this seemingly solid idea was J.J. Thomson, who in 1897 discovered something that changed everything: the electron. Suddenly, those indivisible billiard balls had internal parts. It was like discovering that a solid rock was actually made of even smaller pieces. But this was just the beginning. Ernest Rutherford would soon come along with an experiment that would be even more revolutionary. Rutherford had a brilliant idea. What if we bombarded atoms with particles and see what happens? He fired alpha particles at a thin sheet of gold, expecting them to pass straight through, like bullets going through a paper curtain. But some of these particles bounced right back, as if they had hit something extremely dense and solid. It was like shooting peas at a curtain and watching some of them come flying back at your face. Rutherford was so surprised that he said it was like firing an artillery shell at a tissue paper and watching it bounce back and hit you. This discovery revealed that atoms had a tiny but incredibly dense nucleus at their center, and that's how the proton entered the scene. Rutherford didn't just discover this particle. Unknowingly, he also discovered the piece that might decide when the universe ends. Because the proton isn't just another particle. It's the silent protagonist of one of the deepest questions humanity has ever asked. But the story becomes even more fascinating when we realize that not even the proton is indivisible. In fact, it's made up of even smaller particles called quarks. It's like discovering that what you thought was a solid stone was actually made of smaller pieces, and those pieces were made of even smaller pieces. The proton is composed of 3 quarks, 2 up and 1 down, held together by a force so powerful that we've never been able to separate quarks individually. This discovery led us to what we call the Standard Model of Physics, a kind of instruction, manual for the universe that catalogs all known fundamental particles and the forces that act between them. It's like having the ultimate assembly diagram of reality. And within this model, there are strict rules called conservation laws. Energy cannot be created or destroyed. The total electric charge remains constant, and so on. These laws are like the fundamental rules of a cosmic game that can never be broken. But this is where things get interesting. According to these unbreakable rules, the proton should be absolutely stable. It shouldn't be able to disappear because that would violate the most fundamental laws of physics. It's as if the universe had created an indestructible particle, an eternal building block that would form the foundation of all matter. For decades, physicists accepted this as a foregone conclusion. However, science has a peculiar way of challenging our most basic assumptions. In 1967, a Soviet physicist named Andrei Sakharov asked a seemingly simple but deeply disturbing question. What if the proton isn't as stable as we think? What if, despite all the rules that seem to protect it, it could decay? This idea might seem like mere academic curiosity, but its implications are absolutely monumental. If the proton can decay, then nothing in the universe is truly eternal. Not the atoms in your body, not the stars in the sky, not the distant galaxies. Everything would be built on foundations that would eventually crumble. The possibility of proton decay arises from theories called grand unification, which attempt to explain how all the fundamental forces of the universe are connected. It's like trying to understand how all the instruments in an orchestra work together to create a symphony. These theories are mathematically beautiful, but they make a disturbing prediction. The proton might not be immortal. Now, before you start worrying about the atoms in your body beginning to fall apart, let me reassure you with a timescale that defies any human comprehension. If the proton really does decay, it would take approximately 10 to the 34th power years to do so. To put this in perspective, the current universe is about 13.8 billion years old. The time we're talking about is trillions upon trillions upon trillions of times longer than the current age of the universe. It's like comparing 1 second to the age of all human civilization. And even then, it would be a grossly inadequate comparison. We're talking about a timescale so vast that our language can barely express it. It's a number so large that if you wrote a 1 followed by 34 zeros, you still wouldn't capture the true magnitude of what we're discussing. But here's what's truly fascinating. Even though it's an almost incomprehensible amount of time, it's still finite. And if the proton has this cosmic expiration date, then the universe is, technically, on a countdown. A countdown so slow it's practically imperceptible, but a countdown nonetheless. Imagine the universe 10 to the 34th power years from now. Stars have long since stopped shining. Galaxies have dispersed. Black holes have evaporated through Hawking radiation. All that remains are the last remnants of matter. Cold white dwarfs and silent neutron stars, floating in a dark and frozen cosmos, like cosmic tombstones in an infinite graveyard. And then, very slowly, the final show would begin. The protons in these dead stars would start to decay. Not all at once, but one here, another there, like candles being extinguished one by one in an empty cathedral. Each decay would release a small amount of energy, creating a faint glow. Fainter than an ordinary light bulb. That would be the last breath of these ancient stars. This process wouldn't be dramatic. There would be no explosions or cataclysms. It would be more like watching a photograph fade over geological ages. The very structure of matter silently unraveling, particle by particle, until nothing remained but low-energy radiation scattered across infinitely empty and cold space. But what if we're wrong? What if the proton is truly immortal? This alternative scenario isn't necessarily more comforting. In a universe where protons don't decay, matter persists. But the final outcome might be equally grim. Even with eternal protons, stars would still die from lack of fuel. The universe would still expand and cool. And then, during periods of time that make the lifetime of protons seem brief, something even stranger would happen. The very structures of matter, those dead stars and abandoned planets, would slowly begin to collapse under their own gravity. Through quantum fluctuations and gravitational rearrangements that would take 10 to the 70th power years. Even these last structures would eventually collapse into black holes. And then, through Hawking radiation, even these black holes would evaporate, leaving the universe in a state of absolute heat death. In both scenarios, whether with decaying protons or eternal protons, the final result is surprisingly similar. The universe ends not with a bang, but with a whimper. Not with cosmic drama, but with a deep and irreversible silence. It's an ending that defies our dramatic expectations, being simultaneously more subtle and more profound than any apocalypse we could imagine. What makes this discussion even more fascinating is that we still don't know which scenario is correct. Despite decades of experiments trying to detect proton decay, we've never observed a single proton disappearing. This doesn't prove they're eternal. It just means that if they decay, they do so rarely enough that our current detection methods can't capture the event. There are experiments happening right now in underground laboratories around the world, where scientists observe giant tanks of ultra-pure water, waiting to capture the signal of a single proton decaying. It's like trying to hear the sound of a needle dropping in a gymnasium full of people screaming. These experiments are monuments to human patience and our relentless desire to understand the deepest mysteries of existence. Regardless of which scenario proves correct, one thing is certain. The proton occupies a unique position in cosmic history. This tiny particle, so common that we rarely think about it, could literally be the key to understanding when and how everything we know will come to an end. It's extraordinary to think that the fate of the entire universe might depend on the behavior of something so small that trillions of them would fit on the head of a pin. This realization offers us a humbling perspective on our place in the cosmos. We are made of protons that may have existed since the first moments of the universe, and will continue to exist long after our star burns out, our galaxy disperses, and even after the last star in the universe burns its final atom of fuel. In a very real sense, we are composed of particles that might be the most enduring witnesses to cosmic history. But perhaps the deepest lesson that emerges from this investigation isn't about physics or cosmology, but about the nature of knowledge itself. Here we are, conscious beings made of protons, trying to understand the fate of these very same particles. It's as if the universe had developed a way to study itself, questioning its own mortality through creatures made of the same fundamental components it's investigating. This quest to understand the proton, and through it, the fate of the universe, represents something profoundly human. It's our need to find meaning and understanding, even when confronted with scales of time and space that challenge our comprehension. It's our refusal to accept mysteries without questioning, our determination to push the boundaries of knowledge, no matter how impossible those boundaries might seem. And so, as we contemplate the distant future of the cosmos, we're reminded that every scientific discovery is not an end, but a beginning. Every answer we find opens doors to even deeper questions. The proton may hold secrets about the end of the universe, but even if we unraveled all those secrets, we would certainly discover new mysteries waiting to be explored. Because knowledge is just the beginning.